Okay, everybody, hello again. And today we're going to be talking about what amounts to an application of something that you saw previously, the basics of the Grignard reaction. Today we're going to be talking about how we can apply it. We'll be talking a lot this semester about how we can apply things, with particular reference to organic synthesis, or how we make things. And the things that we're talking about in particular right now are alcohols. How can we make alcohols using the Grignard reaction, or how can we make particular alcohols applying this reaction? Well, before we go on to the application questions that we have coming up in subsequent slides, I just want to have a little bit of a review of what we saw last time. If we wanted to make a primary alcohol like this one, we would have to start with formaldehyde here. Okay, we'd have our two-step Grignard reaction. If you remember, the second step is always H2O plus for protonation, and the first step is addition of your Grignard reagent, your magnesium bromide. In this case, containing 2 carbons, because your product here has 3. Initially, you have 1. So if you wanted to make, say, for example, a secondary alcohol, you'd start from an aldehyde, again using your two-step reaction. Also, we saw that if you wanted to make a tertiary alcohol, you would start from a ketone. So notice the similarity here. 1 carbon, no carbons coming off your carbon bearing the oxygen, 1 carbon coming off the carbon bearing the oxygen. 1 carbon coming off the carbon bearing the oxygen, 2 carbons coming off the carbon bearing the oxygen. 2 carbons coming off the carbon bearing the oxygen, 3 carbons coming off the carbon bearing the oxygen. So we've added a carbon in each case. There was one other way that we actually used to make tertiary alcohols last time, and that was from esters. If you remember, that process was a little bit different. The mechanism was a little bit more involved, and you had to use 2 equivalents of your Grignard reagent, because the first equivalent involved addition to the carbonyl and kicking out of this leaving group. Anyway, here we have some basics for how to make our 3 different types of alcohols. All right, so let's have a look here. How can I make this alcohol using a Grignard reaction? Okay. When it says using a Grignard reaction, that implies you have a Grignard reagent and you have a carbonyl group. Okay. And the thing that we have to go off here is, well, what sort of alcohol do I have? Hopefully you can see, well, I clearly have a primary alcohol. And if I have a primary alcohol, we just go back to our first slide. A primary alcohol, we have to use formaldehyde for that. So that means, okay, well, let's have some formaldehyde. Here's some formaldehyde. Now, formaldehyde, as we've already seen, only has 1 carbon. And how many carbons do we have in our alcohol here? Well, you can count them up. It's 1, 2, 3, 4, 5. So if we have 5 carbons there, let me just delete this really quick. If we have 5 carbons in our product, how many carbons do we want to add in our Grignard reagent? Well, obviously that's not much of a difficult question. Of course, it's 4. So therefore, our Grignard reagent is going to have to contain 4 carbons as well as the magnesium and the bromide. So therefore, that suggests something that looks like this. 1, 2, 3, 4 carbons. 1, 2, 3, 4. The 4th one, or the first one, however you want to name it, bound to the magnesium. Okay. There is your magnesium bromide. In this case, this would be butyl magnesium bromide. If you remember, the second step in every Grignard reaction is always addition of H3O plus. So what we've done is we've shown, well, we needed a primary alcohol, so we have to start with formaldehyde. So, and then because this has 1 carbon and we have 5 in our product, we needed to add 4. So this guy literally comes along here, attacks the carbonyl, kicks the electrons up onto oxygen, which then protonates with H3O plus and gives us this. If we wanted a secondary alcohol, of course, we would start from an aldehyde, and then we just add in our Grignard reagent. It does get more complicated, though, And to let you see an example of that, we're going to look at this. The question is the same as it was last time, except this alcohol is a lot more involved. How can I make this alcohol using a Grignard reaction? Well, first thing, what sort of alcohol do we have? You always want to ask yourself, what alcohol do I have here? And you can see there are 3 carbon groups connected to the carbon bearing the OH, so therefore it's tertiary. So what that tells us, if we go back a couple of slides, that tells us we are going to start from a ketone. Can anybody see why here we actually couldn't use this and start from an ester here? We have 3 different groups coming off this carbon bearing the OH. If we were to start with an ester, we actually add in 2 of the same Grignard reagent, so that isn't going to work. So we're going to have to start from a ketone. The problem we run into is, well, okay, that's fine. I'm going to start from a ketone. The problem is, what are my 2 groups that are going to go here and here? Because look at the groups I have. I have my ethyl, I have my methyl, and I have my phenyl. One of those 3 I'm going to add in, but which one? Does it matter? It actually turns out for the Grignard reaction, in most cases, it doesn't matter. So it actually becomes essentially your choice. All right. So if I was to say, well, here's one option. What if I say I want to add in the methyl group, and so that implies then I would start with my ketone already containing the ethyl and the benzene. Okay, doesn't look very nice, but that's supposed to be a benzene ring there. Well, that looks pretty pathetic. In fact, let me draw that again. Apologies. Well, my drawing skills are not really up to MC Escher. I'm working on it though, so bear with me for a few decades and I might get there. Okay, here's my benzene ring. And we said, if the methyl group is the one I want to add in, well, that implies I have to start with the benzene, with the phenyl group, and with the ethyl already present. Okay? So then I can just say, well, okay, if I want to get to here, in fact, let me just erase that. If I want to get to here, I have to use my Grignard reagent to add in my methyl group. So therefore, what will my Grignard reagent look like? Well, it would contain my bromine and my magnesium, but how many carbons would it contain? Of course, it would contain 1. So it would be CH3, Mg, I can draw that out, MgBr. Of course, we'd have our second step as well, our H3O+. And that's one way to make that alcohol starting from this ketone. But what if you had a question that said, show all the possible ways to make this alcohol? And the way to approach that is to say, well, how many different groups could I potentially add in via a Grignard reaction? Well, I have 3 different groups around my carbon bearing the oxygen here, so that means potentially 3 different groups I could add in. I chose initially to just add in the methyl group, but what if I chose instead to add in the ethyl group? Okay. If I chose to add in the ethyl group via the Grignard reagent, which 2 would I have to start off with in my ketone? Can act all like Sesame Street here and say, yeah, I'm assuming you're giving me the right answers here. So, well, what do we get? Blah, 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 blah. Sorry, that's me being a little stupid. If I was choosing to add in the ethyl group, then that would imply in my original ketone I must already have present the methyl group and the benzene. And then I just add in my, in this case, ethyl magnesium bromide. And second step of H3O+. But you can see there's still a third option. Well, hopefully you can see there's still a third option. What if I wanted to say, well, what about my methyl and my ethyl? What if they are already present in my ketone? Because couldn't I potentially add this in? Couldn't I potentially add this as a nucleophile? The fact is, phenyl magnesium bromide, or pH MgBr is actually quite a common Grignard reagent, as is methyl and ethyl magnesium bromide, but this is actually quite easy to use. A lot of undergraduate laboratories use it. And so, although it might not seem so, it's actually quite possible to use this as a Grignard reagent, which implies then that my starting ketone would have to have my ethyl and my methyl group already present. So we've seen here 3 different methods, all involving the Grignard reaction, to get to a desired product. All right? So with a tertiary alcohol with 3 different groups, it means potentially 3 different ways to make it. If you had a secondary alcohol like this one, hopefully you can see there would be 2 different ways to make it, where you either add the ethyl group in as your Grignard reagent, or you add in your methyl group. Okay, remember, because this is a secondary alcohol, you would start from an aldehyde. Okay. So the more complicated the alcohol, the more potential routes there are. Okay. So that, in essence, is how you use the Grignard reaction in organic synthesis to make an alcohol. So it's good night from me, and it's good night from him as well, and goodbye.